we usually when we used to do our computing on our own device before. Before, why I'm talking it before? Because like if we wanted to develop certain machine learning algorithm or deep learning algorithm, I'll talk about only that perspective, not fully different aspects of cloud. So in that perspective, if we wanted to train and deploy a very huge machine learning or deep learning model, what we used to do, we used to deploy these on-premise, means like I have a home and I have a desk, I have a computer, I purchase some graphics card, I purchase some high RAM memory efficiency thing, and we used to like train on-premise on our home, right? But nowadays, you do not need that. Probably in the classes also, most of the time, professor might use Google Colab, right? So there we can go, you can connect your code with cloud, basically, right? You do not need a GPU. You can just use the virtual ones, right? So that is cloud, and another one is on-premise. So cloud computing versus on-premise has a different distinction. However, sometimes the question comes like, what should be the best solution for us? Which we should use and which we should not, right? So it depends on cases, different use cases, it depends. So before I go to the use cases, I'll give a little bit of hint about those. Several other use cases of cloud computing is you can do data store, backup, and recover and create some cloud native applications. Sometimes you stream audio and video. I believe you guys watch TikTok, YouTube videos, or even right now I am having a conference with you in Zoom. So all these are kind of streaming audio and video together, or even Netflix. So these are the data is hosted through cloud. Deliver software on demand, analyze data, embedded artificial intelligence model. So mainly maybe our curiosity in this last two part, analyze the data, excuse me, and embedded artificial intelligence model. So three important things here. So we talked about a lot of things in the cloud, but three important things is compute, storage, and database. So compute actually computes the thing like Google Colab, right? When you write any algorithms over there or inferencing over there, right? Inferencing means we pass some image to a trained model or we pass some data in a trained model and that can actually tell us the result. So when we're passing it, right, it actually it have to compute. So previously this model used to be in our computer and we used to give the model our data and it gives to give us the result. But now that model, that's computation done in the cloud. So that's kind of the brain of the process. Storage is where should I keep the data, right? So previously we used to keep our data in a local computer. You remember, I don't know like you guys remember or not, but once upon a time we used to carry the USB drives and we keep the our data over there. But nowadays you can move anywhere, you can rely on cloud, right? Because you can keep in the Google Drive, Kakao Drive, anywhere. And also it's pretty important, like it's very secure. How? If you remember in your mobile phone, you were in Korea, definitely. I used to be in Korea, so I used to use Kakao Talk a lot. So if you change your cell phone, right? So what happened, like you get all of your history in new cell phone, right? From previous one. So that is the storage. So it's in the cloud. So what happened, it switched from, if you switch from that your own device to other new device to other device, everything comes there, and it is secure as well. So storage service in the commercial application, we are now using it in cloud. And database is actually also important because all the data in a structured way or unstructured way, you may say we save it in the databases, right? These are the necessity and practical implementations of cloud in our day-to-day life we can see. Okay. So there are few characteristics in the cloud. So I want to just skip this part and open from here because that's what is important. So instead of going to the lot of details about this cloud security, virtualization, or scaling, what probably you already know and have fair idea, I will give some analogy about cloud service models because today you probably have already understood that cloud is kind of a service you take from internet, right? And you can pay money for your service. So let's see like about car analogy. So I have talked initially about on-premise computing and cloud computing, right? So, for example, you can buy a car, right? And so in car, you can actually drive wherever you want to go, you can go. But you have also this Kakao Taxi or Uber, that sort of application, and probably there are a lot other. These are you renting a car. So whenever you need a car, you just call the car from your app or give it a phone, right? So that is actually sort of cloud, you may think. Okay, how I'll tell you. So for example, mm, if you own the car, you have to do everything, right? So you have to buy the car, do the maintenance, give the insurance, clean part, fuel. You have to drive, you have to check the route. But if you just take the car renting service, right? So renting service means you want to travel from your own city to maybe Jeju or somewhere else. You just rent a car. So what would happen at that time, right? So you have to actually pay for the car, do the maintenance. Uh, no, you have to just parking, fuel, and driver and road. For these four things, you have to pay. This IaaS, that is infrastructure as a service, the best example would be you are hiring a car or renting a car, right? Because for example you want to go from your university to your home, so you want do not want to take a public taxi, you want a public bus, you want to take a public taxi or a private taxi. Okay, so if you take a taxi, what will happen? You have to pay the driver, right? And if they wants to drive you to your destination, they have to take the route and pay the fuel and do the parking. So whenever you are paying them money, right? So you are paying money for those things. However, the driver or the company, Kakao Taxi, owns the car, do the maintenance, give the insurance, and do it cleaning. So you actually do not pay for those stuff, right? And you do not actually keep the car with you all the time. So that means infrastructure as a service, IaaS. Okay. Now, other thing is like PaaS, that is platform as a service. So this example could be like ride sharing application, right? Sometimes we can share the ride together, okay? Or sometimes maybe some of the guy come and tell, I don't know, I think this thing is not available in Korea, or it's like a public bus, some sort, okay? So there is a driver and they actually ask people to take the seats. Maybe a car has 3 seats apart from the driver. So people can rent a seat and go in the car, okay, to somewhere else, right? So this is actually platform as a service. So here only you pay for the route you are going to. So three persons are paying for the route. So you do not need to pay for the fuel, driving, parking, nothing. Okay. So that is platform as a service. And then SaaS as a software as a service. So you don't do anything, okay, anything at all. So you just give some money to use that thing. So the best example of this is public transport. You go to the subway, you go to the bus, and done, right? So you are reaching to your destination, but instead you are not paying for anything. Just as you are reaching to the destination, so you give some fee. So that is kind of a software as a service, okay? This is an analogy of car and on-premise. So now let's make it more relatable, right? How? So in the cloud service models, we also have actually these four types mainly: on-premise, IaaS, PS, and SaaS. Okay. So here, like car, on-premise car, if you do everything on-premise, right? You want to run that deep learning application and whatnot, and you want to run some cat dog classification, or maybe you want to forecast some financial data, right? So in your home, you set up a computer. Not only computer, actually, you have to pay for the operating system because when you buy a laptop, I believe the operating system comes with it, but you already, when you're purchasing the laptop, there is money going to the operating system, so you have to pay for the OS you are running. Unless you run Linux or open source, that is free. Also, when you use networking, storage, server, let's say like I want to take like 1 terabyte of storage or 500 GB of storage, right? That is your storage. So you also pay the money. So because when you are paying, you are actually increasing the amount of money based on the service you are purchasing, right? And also you pay for application, right? I'm not going into all the details because which are kindly more relatable to us everyday life. I'm talking about that part. So applications means you probably want to run Microsoft 360, okay, or this sort of applications. You have to pay for that, right, in your computer. However, when you do the infrastructure as a service, you do not pay for all other things. You just pay for networking, storage, server, and virtualization. Okay, and for PaaS platform, you just pay for the other stuff and manage for data and application. So one good example of PaaS would be like your Google Cloud itself, right? So that we you are using day to day probably. Though I do not think it is complete a PaaS service, but somehow you can relate it because if I have a like 10 years, 20 years old computer, I can still use Google Colab for my experiment because I can put my data into Google Drive, okay, and the application I just need a browser in my PC or whatever, and I can use it, right? So that you can think as a platform as a service, okay. And SaaS is software as a service, so here you do nothing actually. That's the complete cloud ecosystem, like Azure Cloud or Amazon Cloud. So what happens? Each of these services, right? Um, each of these services, when we go to the Microsoft Azure or Amazon AWS or any other cloud platform like Google, okay, so they sell everything separately, right? So if they sell everything separately, so you can buy whatever you need. Okay? If you go to the full ecosystem, that means you're buying everything. You don't own anything actually. Okay. So that's interesting. So this is sort of a cloud service model analogy. So the infrastructure as a service, it's just a chart, okay? So one important thing is I can give here is in the SaaS, you do not need to install anything on your computer. And for PaaS platform as a service, most of the time developers use that, okay? So that is enough for this thing. But we are gonna discuss our case study, so we do not need to dive more. And just a little bit about here. So we learned about three things: SaaS, PaaS, and NaaS. So in SaaS, you see software as a service. So you don't own anything. Everything the cloud provider are giving to us, or we are paying the money for that, right? So in that actually is top of the pyramid. Means you do not have much control, but you do. Okay. But when you have infrastructure as a service, right? So you are managing these, but the vendor is managing these part. So in this case, you have certain control over how your things goes on, works on. Control means, you see, you can manage operating system. It's up to you. Windows, Linux, macOS, whatever. What sort of data you want to use, how you store the data, it's up to you. What sort of application you want to use, it's up to you, right? So you have more control. But in past, if you see, you have the control on data and application, whereas middleware, runtime, you have no clue, no idea. Whatever they give you, you have to use it. Okay, you have to configure, use it. Okay. But for SaaS, you don't have any control because it's not your lacking. Whatever is there, you have to use it. Like the subway. If the subway looks dirty, nothing to do. You have to, right? Use it. So, mm, yeah. And there are some other cloud service as well. Nowadays, what happens in cloud, if anything comes as a service, they called as a service, and at the starting, you just put the name. So say I want to sell a function, okay, a part of a software. For example, how would I give a good example? Good example would be yes. So whenever you try to log into any website, there is option, right? Register yourself. So you give your email address, name, date of birth, everything. Okay. And then you can create a address over account over there, and you get authentication code in your email. You go there, you do the thing, right? But there is another option, sign in by Google or sign in by Apple. So what happens? You click there and it goes to like Google window will open or Apple will open, right? And then you just put your Google Gmail login credential and you are done, right? You do not need to do that, fill up the forms and everything. Excuse me. So in that, what is happening over there actually? So Google offering those website like, hey, look, you do not need to do all this thing, okay? It's up to us because we have this guy's information, so they can just tell, okay, sign in by Google, so they can come to us and give our login credential, and I will do the rest for your website, okay? So in this case, what happens? This is a soft a function or focuses on a function, right? So function as a service. So Google is offering that login function as a service to that particular website, right? Whatever website you go, you can do that, right? So that is a function as a service, right? So we learned about SaaS, IaaS, PaaS, whatever, but nowadays function as a service also as a part of cloud service models, okay? And also sometimes identity authentication, payment transaction, okay? So these are over there. So those example I did not see much in Korea day-to-day life because Korean payment transaction. Maybe KakaoTalk would be a good example because when you pay through Kakao Pay, so you have to just do your face ID or fingerprint, whatever. But beneath that, actually, the banking system is working because you connected your card with the Kakao account, right? So how this is work backend because bank is providing support to the Kakao as a function, right? So because of this function, as Kakao is purchasing from the bank, okay, so that is a function part of the cloud. So that's how this thing going on. And there are other services as well, like hardware as a service, storage as a service, database as a service, DBaaS, and disaster recovery as a service, and anything as a service can be cloud, right? It's kind of our day-to-day life. Whatever we sell through cloud can be as a service. So uh, hardware as a service, that's a good example is when you run in Google Colab, you can check over their runtime. Okay, there is option called runtime. So runtime is usually CPU, so you can change it to GPU or TPU. So what is happening over there? Google Cloud is letting you use their cloud hardware, right? So somewhere in the data center or whatnot, they have this servers over there or the GPU, TPU over there. So you from your home, when you're accessing the cloud models, you can actually use hardware even as a service nowadays, right? You can access to a good GPU as a service, okay? When you are deploying this sort of machine learning or deep learning codes, or you probably will soon get these sort of services while playing games probably because still to play the heavyweight games you need a very heavy graphics card because they need to process on device. However, maybe the days will be changing very soon, so that might not be required. So in the presentation I have told about uh, I have talked about the modern cloud. So what we understood about the modern cloud, because the extension from this IaaS, or SaaS nowadays, anything can be a service. Okay. And now in the job market, I definitely for sure after you graduate or after you finish this course, you have to have some good knowledge and where you can apply this type of skills. And if you are interested to learn more about these things, okay, why you should learn it, and why you should gain this sort of knowledge, and why you should understand or relate, um, how can you connect your ongoing research or ongoing work with cloud ecosystem. This is very important to understand and relate. So most in-demand skill nowadays is cloud computing, right? Why? Because you see, even I finished my PhD in 2021. I started in 2017. That time I had access to pretty good libraries. When Professor Jia did his PhD, he did not have access to those things, right? So he had to write codes from scratch. For my case, I did not have to write code from scratch. I used to use sort of libraries, mostly Rust and Surflow, and PyTorch actually came at the end. So I was using this. But nowadays, actually, you sometimes do not need to train your model, right? Sometimes you just download a pre-trained model and just do the inferencing. Inferencing means you can just pass your data to the model, just fit it, right? And you get the result. So now it is actually a building a model rather than building a model, try to understand how a model works and how you can use it for your own purpose becomes a norm. And most of the companies, especially after the chat GPT storm, what happened is most of the people, not everybody knows about AI, right? If you talk with a little kid, probably they will also know about AI. Let's talk about AI. Even a few days back, some school kids were talking to me about AI. So I was just thinking, okay, I did my PhD. I spent like 4 years of time, or 4.5 years of time of my life to understand this thing. And these people are nowadays talking about AI. It's a good thing. It's a good thing because people are trying to understand more and more, but there are a lot of misconception how people understand, and there are certain limitations. But as you are the students and trying to understand it, you have that uh, like practical idea and common sense about how this thing works, and you understand like why this thing works and which cases this thing might work or not, right? That's as a responsible person, the educated person, we need to uh, uh, acknowledge and consider. So, after considering these things, actually, if we want to utilize those things in our day-to-day life, day-to-day activity, we have cloud in a lot of aspects. So, several roles like data scientist, machine learning scientist, data engineer, data analyst, all these cases you need actually cloud computing. Okay. So you have to have a certain familiarity with cloud. And different new roles have been created nowadays. One is cloud architect, cloud engineer, DevOps engineer, security engineer. I will not go into those details, but if you guys want to explore this particular domain, so you can explore, and there are a lot of training on Azure Cloud, Amazon AWS service, Google Cloud. You can have expertise of certain one of the tools, and then in the job market, if you go and you know how to just do a data science project or machine learning project, okay, and you can demonstrate like, okay, this project I have used cloud services over there end to end from start to finish, like deployment. So that time actually will be very good for you to sell yourself in the market, because when you nowadays actually it's pretty interesting because yesterday, maybe not even yesterday, around 16 hours ago, ChatGPT releases a new model, GPT-4o, and I believe it will again change everything, because now the ChatGPT can do, it's pretty interesting. So you can ask it to open a video camera, it can see the image, and it can talk to you like a real human being. Okay, and it's pretty scary good. And now probably they will make it free for everybody. Okay, even Before I used to pay money for ChatGPT per month, the subscription. Nowadays, even any people can use the full premium version of ChatGPT, though there is limitation about like how many texts you can send in an hour. So if I use the payment service, I can send like 30 text messages in an hour. If you are using free, maybe you can send 8 text messages in an hour, right? So it's becoming a norm every day. Okay, and and they also announced they will release a search engine. So we are habituated with Google search engine, but just imagine ChatGPT gets too strong, OpenAI, and they're creating a search engine. So now you do not have to do anything. You have the ChatGPT app in your phone. You go anywhere, you open the video camera, ask it, okay, what do you see? Where is the restaurant? It will just talk to you like human. Oh, I think this restaurant might be good. You can go here and just walk here. This is amazing, right? So you see, everything is moving from on device to cloud. So if this thing happens, you do not need a pretty fancy mobile phone anymore, probably, right? Unless you take a good photo or want to listen music. Even previously, I remember I used to think about like, okay, in my phone, I need to download the songs because I used to listen a lot of songs, okay, or I would like to watch videos. But nowadays, as the internet price is also getting cheaper a little bit, okay, or I have the access to the Wi-Fi everywhere, right? I don't download anything in my phone. So if I purchase a phone with 64 gigabytes or 256 gigabytes of storage, okay, this more than I need actually because I don't download anything. All the time I'm in the browser and I'm doing everything. Sometimes I download applications because still probably sometimes you need certain applications because different services are giving you different applications give different types of services, right? So I use that day to day life. But say like a super app kind of Kakao. So in Kakao, you can do chat, you have a marketplace, everything together, right? You can order food, you can order taxi, so you can pay to your friend, everything. So it's a service itself, right? So a company is dominating that. So the point is day by day, the cloud service are getting very, very popular, and not only popular, it's in our day-to-day life. So you have to realize that thing, okay? And you have to understand and you have to learn these necessary skills. If we do not have these skills, actually, we are lagging behind. Nowadays, if you go and say, oh, I know how CNN works, or I know how this transformer model works, it's not really, I mean, nowadays all. You have to know, pay attention to, and understand how these things work as a whole. That is why when probably professor asked you to uh, think about how you can use cloud in your own application or in your own research, that is really, really important, okay? Because you need to think rather than demonstrate. First you need to think, first you need to search, and first you need to understand. And I will give you several examples, definitely, like Professor probably today gave already, and before that he also gave presented a lot of nice things. So different players are there. Microsoft Azure, you know, I told you, AWS, IBM Cloud, Tencent Cloud, Alibaba Cloud. But in the market, I just wanted to share this thing because if you think, okay, I want to learn and you see, oh, there is Oracle Cloud, it's pretty fancy, nobody learning this. No, don't go for this 2% thing, okay? If you want to learn these three: AWS, Microsoft Azure, Google Cloud. Okay. I think in your day-to-day life, in our day-to-day life, we can use Google Cloud a lot. Amazon AWS, we cannot use much because it needs money. And as a student, as an open source learner, I do not want to spend any money to use cloud service. Okay. But for Google Cloud, yeah, this we are using every day. But nowadays I use AWS service, sometimes Microsoft Azure, because I work here, they pay money, so I use their service, I have to. So that's a different aspect. So most of the companies I have seen, they're using these three: AWS, Microsoft Azure, Google Cloud. Unless you go to some company specific to related to Chinese e-commerce ecosystem, then Alibaba probably, and I'm not sure, probably Kakao might, Naver might release some sort of cloud. So if you are based in Korea, if you want to pay attention to the market, You can also search into that and understand that thing, okay, and try to learn that thing, because it's about how you can use the service. You do not need to understand like how each and every components work, because it's sort of kind of now literacy about how you use Microsoft PowerPoint or Excel or a browser, like that. You have to connect everything. That's it. So I want to give a case study before I go to my case study itself. So there is a Google Cloud case study from UK, and this is pretty interesting. Okay. So what is the case study? There is a soap company called Lush. Okay, so it's a pretty fancy soap company. So they actually sell good cosmetics products. So every year in UK or in the US, there is a Black Friday. Okay, I think US is Boxing Day, in UK we call it Black Friday. So here they typically sells a lot of stuffs and give a lot of discounts. So what happened? They released a website, and when in the Black Friday, a couple of years back, people started to come to that website, the website started crashing. Okay, because there are a lot of loads over there, the efficiency was not much. So they thought, okay, can we just make the infrastructure to Google Cloud? So what Cloud does here is this previously used to monitor like this load balancing, right? Load balancing means, okay, in an hour, how many user can come to my website and how many user cannot come to my website. Okay, how many per minute, how much transaction I can make, how much transaction I can make. I gave a good example of ChatGPT, right? I told in a minute you can send like in a 3 hours you can send 8 text messages or 30 text messages. So they gave a limitation over there. You see, so that is the limit controlling they are doing a resource management intel. Okay, because when I go to OpenAI write something, I am a resource by myself. Okay, I go to that website and that website is giving me service. So what happened, this last website, when there are millions of users enter into that website in a single minute, okay, website started crashing. So what they did, they thought, okay, let's move it, migrate to the cloud system, Google Cloud, just purchase complete service from Google Cloud, keep the data, to handle the data, to host the website, everything. They did not host it separately, right? Before you used to purchase different servers, different stuff to do something. They did not do that. So what was the improvement happened? So one improvement was no outage during Boxing Day or the Black Friday. Okay. And 40% reduction in hosting costs. This is pretty important. This sometimes in some cases study you need to think about not only using the technology but why you are using that technology. That is important. Okay, it's not always about humanity, to be honest. Sometimes you need to think about uh, the business value of it. Okay, and that's the modern cloud ecosystem, because when you want to do something, okay, you have to understand how much money you are trying to save when you are using this service. So when they took different services and they tried to host the website in their own server, they had to spend a lot of money. But when they purchased the Google, okay, cloud completely, they reduced the hosting cost by 40%. I told you about a new role, cloud architect. You know, like what cloud architect does. They have the knowledge about all this stuff. And when I, as a customer, comes to you and asks you about, oh, okay, I want to build this application. Can you tell me how I can build this application and which technology might be good for making this thing? So you gave him or that person, okay, you can use this technology. That's one part. Another part as a cloud architect, you have to tell him, okay, if you use this combination, you get this benefit, and that gives you this much amount of money costing every year. So for every case, on-premise, infrastructure as a service, cloud as a service, function as a service, you can suggest that person every aspects of the things with the money in that. Okay. So at the end, the me as a person, when I try to purchase anything from you, I will give my preference. Okay, I want to buy this or I want to buy that. Okay. So that's the case study of Lush. Before I go into my own example, now I start my own example based on all the things I have discussed here. If you have any question, you can ask me. Any questions, please, if you have anything to ask about this stuff. Okay, okay, sure. Okay. So when I started my PhD, actually, my motivation was to work in energy sector. Okay, because I thought energy sector, working in energy sector would be really nice. Why? Because as the cloud service, as the computation power is, we are using too much. So in the everyday to day life, actually, we are relying more on energy. Okay. So there are three major sources of energy: coal, gas, and oil. So how we are relying on energy every day? You are using more electricity, more computing power. Even nowadays, we are trying to drive the electric vehicle, right? So that needs battery, and you charge it. Okay. Before that, people are commuting a lot, so they use fossil fuel. Fossil fuel is this gas and oil, okay? So when we are collecting this fossil fuel from our environment, what happened? We were destroying the natural resources, okay? So that's a pretty concerning factor, though as a human, we just use it. We don't care what's going on over there. We just get the service and done, okay? But sometimes you need to think about that as if you want to do research or if you want to do solve some actual problem, right? So that was the motivation over there, okay? And but I thought, okay, with this thing, actually, a lot of carbon dioxide gas was emitting, and that is actually creating problem with the greenhouse effect. So that actually created a lot of temperature changes and a lot of stuff. So, okay, as a researcher, as a person, I cannot actually save all the things, right? I am not a Superman or a like superhero, right? To save all the things. But what we can do, or I could do, is okay, let's consider about certain use cases and try to contribute over there. So if I contribute very small amount of thing over there, that particular thing, maybe that might contribute to the whole overall problem. So if I can contribute maybe 0.01%, maybe like me, there are millions of people are contributing 0.01%, right? So that's a million percentage you can tell. So the contribution should not be always you are solving everything overnight. You can contribute little, but that's okay. So I choose to work in industrial fault diagnosis. Okay. And what do I mean by industrial fault diagnosis? Because in industry, when machines are running, there were energy involved over there. So we wanted to make sure, okay, if we run a machine, the machine is in good condition, because if we waste energy, waste the money over there, if the machine is faulty, that might be more problem, right? So I used to work in this fault diagnosis part, mostly for things: preventive maintenance, reliability centered maintenance, predictive maintenance, and run to failure. Professor probably in last week already, or in the last class, already gave you several examples of this bearing fault diagnosis or this sort of uh, research details, right? So actually, those sort of research we did for mainly this solve saving energy problem purpose. Okay, under the broader hood. So I worked in different areas. One was bearing fault diagnosis, oil and gas tank fault diagnosis, spray palm fault diagnosis. Also, I was fortunate enough to work on some topics of the workers' health and safety, because still humans are doing everything right. And in Korean society or Asian society, I would say we work really hard. Okay, and sometimes we work too much, we forget about ourselves. So it is important to take care of your mental health as well. So I had a chance of working on that stuff, because it's important to assess the workers' health and safety condition as well. Because unless workers are health and uh, maintain health and safety, how they can tackle the machine, right? Still human operators are there. So while doing that, I actually investigated the data-driven analysis, because you see, I my background is computer science and engineering, and I am trying to understand a problem that is happening in real world, and I'm trying to contribute over there. But for me, if I now want to understand, like, okay, how a motor works, okay, how a bearing works, how a pipeline works, sometimes I don't have that much idea, right? Okay, how this machine works. Okay, say I ask you, go and my refrigerator is now gone. So please come to my home and fix it. Can you do that? Most of the time, no. If you do not have any idea about how that thing works, right? So I wanted to be a decision maker. Okay. I wanted to tell, okay, you are the maker, right? So I wanted to tell you, okay, there is a problem here. So come and please fix it. Okay. But I need to tell you, how do we understand like what is happening over there? And I actually don't know how each of these machine moves. So I relied on data driven analysis. Okay. What does it mean? It means a lot of sensors were attached to this motor or this elements. Okay, and from the sensors I used to get data. Okay, and after getting the data, I did feature engineering, I did machine learning, I did signal processing, uh, deep learning, image processing sometimes, and then I used artificial intelligence to give the decision, right? So after this prompt decision, actually I could predict, okay, maybe in these days the machine might fail. Maybe now the signal is abnormal, so somebody needs to check it, okay? Or maybe this human operator is having some bad day because he or she did not sleep last night pretty well. So this sort of decision I used to give, and probably you can give too, because nowadays you do not need to understand how banking system work. You can forecast the stock prediction based on the data itself. So what you need to really understand and communicate is with the data itself, how you can maintain the pipeline, which model you need to use, and how you can leverage cloud technology in your pipeline, right? So that is our motivation. And I also work with this pipeline fault diagnosis. This I am currently also doing. Sometimes wind turbine you can see, because these are the future energy sources. So this is a pretty concerning thing, an interesting case. So now I want to give you a little bit idea about what R&D I did in South Korea. Probably I'm not repeating what already Professor Jia explained to you. Those are pretty nice case studies. I'm talking about little bit different ones. So I had a chance of real-time implementation of anomaly detection of a storage tank, oil and gas storage tank. Okay. So what happened? This is the storage tank. Okay. And we attach several sensors right here. This is the sensors, several sensors in different places. So sensor placement is also a job. Okay. So when you are a data engineer, you sometimes have to take care about how you place the sensor. But this sensor placement is a part of subject matter expert job. What is subject matter expert? Those guys are mechanical engineer work with tank. Am I a mechanical engineer? No. Okay. So this was not part of my job. So, but what they did is they attached the sensor, they collected the data, stored that in this computer system. Okay. Now I was sitting in my office room. Was I here? No. This computer system is an on-premise cloud device. Okay. And they uploaded everything into the cloud server. Okay. Cloud server, somewhere in the cloud, this data was there. And what I could see from my computer is okay, this diagram, and these are the sensor locations I could say. And if I used to click here, I could get the data. Okay, how? Because these data were collected and uploaded to cloud. And from here, if I clicked in my computer, I used to download the data, right? So that means what happened here, cloud technology was used. Okay, because the data I collected in real time from cloud, right? After that, what happened? These, I built a model first, okay? And I thought, okay, I did the feature engineering. I selected features. What is feature engineering? From the data, I did signal processing. I try to understand the feature distribution of the data. And then I try to tell, okay, this feature might be most important one, the second important. Then I build a machine learning model or AI model, okay, to tell me, okay, maybe the signal has a problem. Maybe the problem occurred this red dot, this blue dot, okay, like this area. So I built that model in my computer. And then what happened when I downloaded this data and passed the data to my model, this model used to give a real-time prediction. Okay, where is the crack and where is it? Is it a crack or is it not? So in here, there was another computer to the operator. So they used to see, okay, there is the crack. There is the location of the crack, right? So how it is going? So from here, data storing here, it goes to cloud. I am sitting in my computer. I build this model, right? I download the data or the data comes to my model, okay? And then give prediction, but this prediction directly goes here. So this operator now know, like there is a problem over there, right? This is a full This is actually a hybrid cloud ecosystem because everything we did not do in cloud because we did not need everything, right? Because we could do everything in Amazon service. I told you it depends on the use cases. So not always you need everything in cloud, but you need to understand which part is coming from cloud, which part I can relate to cloud. Okay. So that's a real-time implementation of anomaly detection of a storage tank. I have a publication about that thing as well. However, I'm not including here, just I'm talking about overall case study. Then we build a stress detection algorithm or stress detection mechanism in worker health and safety. How did we do that? Okay, so there was a worker in the industry. Okay, so we may in our team there are few hardware experts, so they build a helmet. In the helmet there was sensors, they placed it, and the workers used to wear the sensors, okay, and in their mobile app or in their system they used to see, okay, you are now stressed, you are now this, you are now that, how they used to get that result. Okay, because I led a team, and by myself, I analyzed this data first collected from these people, okay, or this worker, and developed a machine learning model, and it was pretty good. And then what happened? Whenever the sensor was deployed as a helmet, these model and these data was connected in the cloud. Okay, so the same thing was happening. The data was coming to the cloud. In the cloud I uploaded my model, okay, and it is giving prediction and it is going back to this guy's mobile phone, okay, or the system. That's how we detected a real-time system. So the analysis I did on my computer, but after the analysis has been done, I uploaded the model in the cloud. So in the cloud, what it was doing, this data processing pipeline was running. What is pipeline? Pipeline is the data first came to the model, and then the pre-processing step done, annotation done, features done, and then finally classification done. So all the steps will be performed on the test data, that is inferencing in real time. Okay. So I did the EEG, electroencephalography signal, we tell, based stress detection with using cloud. Okay, the cloud technology has been used here, and the device probably I have checked it last year. They are now selling it in Korean market probably. So the another one is it is pipeline leak detection and localization. Okay, so in this work actually the same thing happened like here. So we put two sensors over there and we created some leaks over there. This data was passed to the cloud, and in the cloud we uploaded our model. Okay, and when we uploaded the model in the system, it was showing like this. Okay, and we're telling, oh, here is the leak location. So basically, in all this work, how we leveraged the cloud technology, we only used the data-driven mechanism. So in two steps, we used cloud. One, we took the data in the cloud, and then we got the data from cloud, and then the data came into sometimes the cloud server, sometimes our own server, give us the result, and then we send the result to the cloud so that other person get it. It's kind of I am sending a text message to your phone, so I am writing a message in my mobile phone, and I am sending it through cloud, right? Through internet. It's cloud sort of, right? My message is going to Google or Apple's iCloud, and then they are sending it to you in the iMessage or Kakao message, right? It's going into the Kakao cloud and sharing with you. So this two-way communication is done here through cloud technology. Okay, so this is a use case of cloud I did in South Korea. Moved to UK, I had a pretty good time understanding cloud in a far better way. Okay, this case study was the first case study and first project I did in UK. And I was at the main lead of this project in terms of the development. Okay, and that time I had the overall understanding about what's going on beneath, but I did not do this sort of project before. As you see, most of the projects are on signal processing, so I came into a different area like computer vision, automation. Here we were trying to solve a pretty important and interesting problem, and it was actually a real life because we are directly working with established company in Scotland. Okay, so it was pretty interesting. So what happened? You see this building right here. Sometimes what happened in these areas, these buildings are pretty old, 1900, sometimes 1800 build buildings, and all over Europe. So what happened? Sometimes in these buildings, isolation is not good. Means when it is winter, if you turn on the heater inside, you still feel cold because in the building they cannot actually keep the heat sealed like a flask. Okay, so you keep hot water inside of the flask. It keeps it in that temperature, but if it leaks, starting the temperature started leaking. So eventually the temperature of the water falls down. So it's like that analogy. Okay. So this is kind of a thermography camera. Okay. So what it does is it takes the picture of the building, and from this color value, it understands which part of the building is now very hot. So you see this red part is very hot. Okay. And the green part is actually okay. There are several color temperature code over here. So from this color analogy, you try to understand, and also there is not only this color analogy, there are different values over there in the data. I'm not going into the data description. So you could understand, okay, there might be a problem. So what company wants to do is, previously they used to do collect that data and they manually understand, okay, maybe this part is the problem, that part is the problem, and then they go to that household or that office and they say, okay, I see there is the problem, so you need to actually repair that part. So now the good question here is, if I want to repair that part, what is my benefit, right? Benefit is my energy bill will be less. I do not need to run the heater 24 hours, right? I can run the heater for 2 hours and then I can turn it off because it's now like flask. I keep the temperature, right? So you see, for energy, we previously I were helping indirectly, but now it's a direct problem. That's I got pretty interested doing that. So how we use cloud technology over here, okay? So in Scotland, there are 5 or 7 cities. This company have people. This company have office. So every day, these guys used to go to different household buildings, okay, and capture these images with the camera, and they used to upload these images in the cloud. Okay. So what we had to do is we had to access the data from cloud and we have to process the data in cloud because you see every day we used to get maybe around 1,000 or 2,000 images, and these tests were conducted around 2 months. So you can understand there is a huge amount of data, right? So if you think previously what I used to do, the data was uploaded in the cloud, and we downloaded the data, we process the data in my computer, and then do the model, and then upload that model inference in the cloud. Okay, that was on premise, but here to deal this big amount of data, we could not do it on our computer, okay, because we needed much more GPU. So what we did, we purchased Amazon Cloud Service. Okay, so what we did is this data was uploaded in the Amazon Cloud Service. In the Amazon Cloud Service, we wrote the code how we can process the data. Okay, so whenever these guys were uploading the data in the cloud, okay, data was processed automatically because we gave the logic, we gave the code over there, okay, and it was done in the cloud. We did not do anything. We just try to understand how the data works. We understood some proof of concept first. We downloaded some data, we tried to analyze the data, and then we say, okay, if this method is done on the data, it's perfect, so let's upload it in the cloud. Okay, we did it. Then we downloaded few chunks of data that we call offline training. Okay, maybe we had data like 50,000 images, maybe within a week or more than that. But this model was like, it was pretty interesting because this test is still going, right? So we downloaded 50,000 images, and with our computer, we could not train. So what we did is with these 50,000 images, we actually annotate the images in our computer, different computers we have used, and we actually manually try to understand the data quality is good because that as a researcher you have to do. Data quality you should analyze by yourself. Feature anything you should analyze by yourself at first. So now around 50,000 data, we did it in our computer, different computers. Okay, so we worked here around 7 or 8 people to do this annotation, data quality assessment, and also different subject experts like these guys who did this data collection. They also came and they help us to understand the data. And then what we did is we build a model. Okay, we got certain accuracy. The accuracy was around 82%. Okay, real world is not 100% accuracy. Okay, if you get 82, 85, that's huge because how much money you want to save, that's the important question in real world case study. Okay, so what happened is we created this model, okay, and this model, what it used to do, if we feed an image, it could tell us, okay, this part is the problem, and then they remove this part from the images, okay, and then these images can show, okay, these parts are quite good, the black part you need to just tackle it, okay, somehow just fix it, whatever, okay. So then once we built the model, we uploaded the model, the final model to the Amazon cloud. Okay. Now it's pretty interesting. These guys now uploaded data. Okay. Data is processed and then data directly go to our model. Okay. And after the model runs, data gives us the performance. So we try to understand how the performance degrades over time. We call it like the performance degradations over time. We can check it. So first week the performance was 82. The second week data we have seen it was around 80%, and the third week it was like 50%. It dropped till 50%. Why? Because that is also important in the cloud ecosystem. Okay, because you see, I told you to design some case specific problem, right? Like this, or maybe I would say, are you happy or sad? So mostly in the human, happy or sadness do not change over time, right? So it is pretty constant. So if you build a model, a cat and dog image do not change much. And if you upload it to the cloud, it will pretty much perform everywhere similarly. But these are very case specific problem because this sometimes affected by weather, sometimes affected by the material of the property. So different city has different material of buildings in UK. So for example, my city buildings are created with granite. Some other city buildings are created with marble. Some other city buildings are created with cement. So when they are collecting the data distribution was changing a lot in real time. Okay, so throughout the, and also sometimes operators are different, right? So they are not operating the machine in same way. Somebody is taking the picture from this angle, somebody is taking the picture from another angle, right? So that is also important. So the importance of data is pretty interesting. So when we uploaded the model to the cloud, we needed to understand why the performance was degrading. So now what we did in the second phase, we with the new data, we again changed the model and we uploaded the model in the cloud after maybe 2 months interval. Okay. So now what happened after 2 months? The model has started performing again 82%, sometimes even better, 85%. So gradually we are improving the model. But how? Through cloud technology leveraging. Because you see, here if we wanted to do like this, maybe millions of data of 2 months all together, and train a model, we needed to purchase a GPU, we needed to purchase a heavyweight computer, RAM, and this cost a lot of money, right? We didn't want to do that. And also, some of our business partners wanted to use an application. They wanted to say, oh, I want to just upload an image and want to see how it works. But no, we also gave them the software because we did not do anything else. We just build a software interface, gave them option to upload the image. That image was actually uploaded to the cloud and do the same stuff, giving us the result, but in the interface they were just seeing it. Okay, so this work I did got featured in the Scottish government news portal, and it was pretty milestone for Scotland to tackle the fuel poverty, and it was a pretty good understanding for me, like how cloud technology can be leveraged in this research work. Okay, so it was pretty nice. And then another work I want to present right now, I told in the beginning, I am currently leading tech lead the CSense project. So I was first as a researcher in this project, but after the success of the previous project, because two guys actually left the job, so I had to manage this thing in time. Thanks to the cloud technology, I could do that. So that's why you need to learn about cloud, because sometimes you need to take prompt decision with your head only. You cannot just do all the work, right? And you can just give a solution. Sometimes you have to think a little bit different way. So I got a trust over there, and then the center gave me the charge of doing the tech lead for this particular project. This is quite interesting project. So uh, we are actually trying to automate the underwater inspection system. Okay, and this work I have been involved in more than, I think, around 2 years right now. So what happens? This is the underwater ROV. This is the toy ROV definitely, but we are actually dealing with the original ROV. Okay, big one. And there we have the LiDAR, stereo camera, and sonar sensor over there. We are processing each individual data, and then we are feeding each individual data together with multimodal fusion, we tell, because we try to see, okay, how the LiDAR data work, how the stereo data work, and sonar data work, and then we try to understand anode crack, leakage, and corrosion. Here we are also using the cloud technology, though it is underwater. We cannot directly use cloud technology underwater because underwater communication is very, very difficult. Okay, so how we are doing it? So the ROV is going to the underwater, okay, and then it is collecting the data. Once the ROV come back to the shore of the ship or maybe the ocean side, okay, because I do not travel to the ocean or North Sea. I am sitting in my home or sometimes in the office, okay. So they come there, they upload the data to the cloud, and we are doing the same system, okay. We downloaded several data, we try to understand each of the data. So I mostly take care of sonar, and my team take care of lighter and stereo. And then actually my model gives a output, other guy model gives a output, other guy gives an output, and all three output merge together. and give us real-time update. And there is also a software developer, so they actually try to generate this sort of interface. It's a fancy interface, and so that the business partners can see. Still, we are working on this project. It's not yet completed, but here I can show you some interesting factors. So this is the sonar sensor, and this is also the sonar sensor. It looks underwater. So you see here is a pipe, but in the sonar you do not see the pipe directly, right? You see some kind of marking over there, so you cannot say this is pipe. So we, for sure, I had to understand data, and it was a very important part to understand the data. Okay, whatever you do, try to understand the data, but try to understand how cloud technology you can leverage the cloud technology over there. And when we collected the data from different sonar sensors, we tried to improve the quality of the images through different AI machine learning techniques. But here we did not use actually cloud. What we did is we downloaded the data, we did it on our computer, we tried to understand the model, and at the end we uploaded the model to the cloud, right? But inside we did this stuff, and this is how the images got improved. So this image we collected, we did not see anything, and then when we improve the images, the result looks like this. So now you see a lot of improvement here. So also with this small sensor, we did some experiment with Robert Gordon University. It's just a glimpse. I want to show how exciting the work is, the research is over here, and the practical work. And then we collected the data, okay? And you see, it's pretty interesting. You see, in this pool, there is nothing. It's an empty pool, right? So you see the sonar data looks like this. I think you guys never see the sonar data, okay? That's why I put it here. And this is a pipe, okay? And you see here is a pipe. So how can you tell this is a pipe? So you have to understand the data by practical application. And actually in this room, I spent almost 3 months with one of my student and one researcher from France. And we tried to understand this thing, and it was pretty good time last summer. So now you see we have two objects here. One is here, one is here. So one object here we see, one object here we see. But there is very much complicacy in the data. So the point is, whatever complicacy you get, you have to do something, right? So here it's a good example. Okay, we collected the actual data like this. So this was a small mini pool. Okay, so you see when we collected the data, this was the pool boundary or aquarium boundary, and I developed a model. So there actually removed all the noises, only the boundaries were there. Okay, and this was a pretty good result I have got. I did not yet publish any paper with this, but I'm thinking to do something because it's a pretty good advancement. So where was the pipe, and we developed some models. So then actually what happened right now, we uploaded this model to the cloud, and we are trying to understand how the model performs over the time. Okay. So we also used a stereo vision camera. So you see in the pool, there is a bucket and a pipe, and you see the infrared images are here, and this is the depth map. Okay, we try to understand this. So you see, what is multimodal is we are trying to understand everything from we try to understand certain object from different sense or different perspective and give results. Why? Because in the sonar you see, you cannot directly tell this is a pipe or not. Okay, and here also you can see, you cannot directly tell, okay, what is here in the depth map. Okay, sometimes the image looks bad. So what happens, from each module you get result, and you merge all the result together to give a constructive decision. Okay, but how you give the constructive decision, because three models work in three different places, right? But we need to do it all together. So we are using cloud technology over here to give us a decision or inference. So that is how the things work. So here is the joystick system. When these guys are operating the ROV, this is the ROV. ROV is going to the target object, and there is the attachment of these sensors with this ROV. Okay, these sensors are connected with this on-device PC, Jetson Nano, or this type of microcomputers, powerful ones nowadays, and these come to this PC operating system. So here sometimes we give on-device decision. Sometimes we pass this data. When this guy come to the ground, we take it to the cloud, try to understand the data because underwater cloud communication is difficult. So in a nutshell, you have to understand your case study pretty good way. Try to understand when to use cloud, what to use cloud, and how we can use cloud. And you need to think. Maybe you never thought about it. You are maybe using cloud every day in your data analysis, but maybe you don't know. Okay, it's time to think actually how you can leverage the thing. And thank you for your time and attention, and thanks, Professor, for letting me present my work. I hope I shared something that might be useful. Thank you.
Any question? More questions? Good. So thank you. Actually, your presentation was very informative and interesting, especially the practical part, right? So how the companies are solving the real-time problem using the cloud and different type of sensor. So that was very interesting part. Actually, I hope that my students enjoyed your uh, practical presentation. So just I have a question. Okay,
Sure.
what kind of skills the companies is looking for from my students?
That's a good question,
After
actually.
completing the degree, if they want to start the career as a cloud engineer, right? In the cloud computing, there are several types of engineers. So what type of skill they should have to become an engineer like you?
Okay, so one part is definitely like to understand the machine learning and deep learning pipeline, how they can use feature engineering, which I believe they are already doing in the class and in the Woosong University. So that's one part. So they have to first of all they have to understand more about the real time case study, how much case study you can solve, you can knowledge expand to. That's the first part. Okay, second part is the cloud part actually. Maybe first you can try with using the open source cloud technologies which are available like Google Cloud. I think it's open source. So try to understand how this cloud technology works. Do some projects using this cloud technology, embedding in your current project. Thirdly, if you want to go a little bit further, there are several courses online. So you can learn either Azure Cloud or AWS Cloud. So when you do that coursework, what will happen is you have the hands-on understanding of how their tools work, right? So you know how the tool work, okay? And now if you go for a company interview, I think it's pretty good. So you have all the knowledges. Now in the company, how they use it, you just have to use it in their way. So yeah, and you have to be confident. That's another thing. Yeah.
Thank
But you
you.
have to pay attention, like what you are doing. Just if your friend do something for you, that will not gonna help for sure.
Yeah, that means we should use the cloud, for to solve some problem. Okay, cloud cannot solve any problem by itself. Okay, we will use the cloud to solve our problem, real life problem, right?
Yes.
Yeah. Okay. So thank you. And actually, from the previous lecture as well as from today's lecture, what we have learned, we have learned how we can solve the real life problem using the cloud. Okay? So thank you, Junaid, again for your time and effort. Okay, we really enjoyed your presentation. Okay, thank you.
Thank you, Professor.
Hello,
Thank you,
Masjid.
everyone.
Again, you
Stay
should give
safe.
a big hand for him.
Thank you.
Okay, bye.
Thank you. Bye.